Alright, find the exact value by using a sum or difference identity. 75 degrees. 75 degrees can be written in lots of different ways. 75 degrees could be 74 plus 1, or it could be 60 plus 15, or it could be 45 plus 30. If we're just using whole numbers, if we continue with subtraction as well to get the difference, there's an infinite number of possibilities. So which one do we want to focus on? Well, 75 degrees, I do not know cosine 75 degrees by heart. My calculator can compute it, but it's not very nice. However, I do know 45 degrees, cosine of 45 and sine of 45, and also 30. So expressing 75 as 45 plus 30 will allow me to simplify to values that I know in the unit circle. 60, I can do 60, but I can't do 15, so that's not a good one. And 74 and 1, I don't know any of those on the unit circle. But 45 and 30, I do. So we're going to express our cosine 75 as a sum, cosine of 45 degrees plus 30 degrees. All right, now we use our identity. The identity we're going to work with is cosine of alpha plus beta equals cosine alpha, cosine beta, opposite symbol minus sine alpha, sine beta. So in our case, cosine 45 degrees plus 30 degrees is going to be cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay, cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Minus sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. These values you need to know. One way or the other, if you have a little chart that you create, or if it's just all in your memory, you need to know these without using your calculator. Now the first one we get square root of 6 over 4. The second one we get square root of 2 over 4. This is commonly written with a common denominator, square root of 6 minus square root of 2. That's the exact value without using a calculator. All right, continuing on. Same question, except for we're in radians. And now we have 21/12. All right, so here we go back to 21/12. Don't worry about the pi for a minute. We've got to get the fractions first. What is that all at? There we go. In terms of twelfths, 21 could be 20 and 1. But these aren't nice unit circle values. So we're looking for two that add up. Let's see, 11, 12, how about 8? 8 twelfths and 13 twelfths. That's still not good. 7 and 14, 6 and 15. Maybe there. Or 9 and 12. Oh, there's a good one. How about 9 twelfths plus 12 twelfths? Now, 9 twelfths is 3/4. 12 twelfths is 1. In terms of pies, 3 pi fourths is a value I can handle, and pi is a value I can handle. So this is going to work out. It took a little bit, but we have that we can rewrite cosine 21 pi twelfths as cosine 3 pi fourths. This value is a value I understand from the unit circle, so it's making me wonder what's up with this problem, and I just figured it out. So we have 21 pi twelfths. That reduces. Now you wouldn't do it this way because they specified by using a sum and or a difference, but that reduces because cosine of 21 pi twelfths, we can divide by 3 and get cosine of 7 pi fourths. which is a pi-fourths in the fourth quadrant. Cosine of pi-fourths is square root of 2 over 2. Fourth quadrant, cosine is positive. That's why we have the correct answer, square root of 2 over 2. But we did it using an identity. All right, next question. This is cosine, cosine, sine, sine. But this time we have the other side of the identity. So cosine, cosine, sine, sine is a sum or a difference cosine angle formula. Now we have cosine of alpha plus beta equals cosine alpha, cosine beta, opposite sign, sine alpha, sine beta. We're looking at the right side here. So I see that alpha is 5, beta is 40, and the symbol, the minus, tells me that I'm going to have a plus. So I can work all that out to recognize that this is cosine of alpha plus beta, which is cosine of 5 degrees plus 45 degrees. That is cosine of, oh, I was wrong. I'm ahead of myself. 5 degrees plus 40 degrees. Again, back to the problem. We have 5 and 40. 5 and 40. So 5 plus 40 is cosine of 45 degrees, which is square root 2 over 2. That completes this problem. Next. Cofunction of a complementary angle. All right, the cofunctions for cosine. Cosine alpha equals sine of pi halves minus alpha. This could also be cosine of alpha equals sine 90 degrees minus alpha, depending on if you're in radian or degree mode. For our problem, we're doing the radians because we have pi's and not degree symbols. So what you have to do here is cosine of pi 24ths equals sine of pi halves minus pi 24th. All you have to do is take your identity. We have alpha. Whoa. We have alpha, pi 24ths. That's going to go in alpha, and it's going to go in alpha. That's all we've done. Just because I have a fancy thing, alpha is going to go there and there. Done. All right, this is too fun. So we have sine of pi halves is 22. Let's see, now we're doing fractions. And we get 11 pi over 24. We have written in terms of the cofunction, so instead of cosine, it's cofunction sine, and the complementary angle. Pi 24ths and 11 pi 24ths are complementary angles because they add up to 12 pi 24ths. That would be pi halves. All right, next question. Okay, let me double check the wording. This is still a right in terms of the cofunction of the complementary angle. For cotangent, cotangent alpha is the cofunction is tangent. Tangent and cotangent, sine and cosine, secant and cosecant. Those are the complementary pairs. And it's always, sorry, something just popped up. It is always pi halves minus the alpha. Well, all of a sudden my writing got bad. Let's try that again. Pi halves minus alpha. It could also be 90 degrees minus alpha. So we're going to plug in 17 pi eighths into alphas, and we get cotangent of 17 pi 18ths equals tangent of pi halves minus 17 pi 18ths, which simplifies to tangent of negative 4 pi ninths. Now, knowing tangent is odd, you could pull this negative out in front and write it negative tangent 4 pi ninths. However, in this problem, since we're asking for in terms of a cofunction, not the negative of the cofunction, we'd leave it as just tangent. That completes this problem. All right, find cosine A plus B. Now when we're given information like sine A equals -1/2 and A is in quadrant 4, we can immediately go to a quadrant 4 angle to represent A. Sine is -1/2. Opposite of sine is -1. Hypotenuse is 2. Running the Pythagorean theorem, we get that the adjacent would be square root 3. You can plug in C is 2 and A is -1 and get B is square root 3. And it's positive. I know these signs. To the right is positive, down is negative, and hypotenuse is always positive. That's A. Similarly, B is in quadrant 2, so we can set up a nice triangle for B. Sine of B is 1/4, so that's 1 and 4. And Pythagorean theorem gives us square root negative square root 15. I know it's negative because it's left. And I know this 1 is positive because it's up. And the hypotenuse is always positive. And now the square root of 15, basically we have a squared plus b squared equals c squared. So if we take c squared, 16, minus b squared, 1, we get 15, and square root that. All right, now that we have that, we can go into our cosine of a plus b. The identity says this is cosine A, cosine B, opposite symbol, minus sine A, sine B. Now we know cosine A. Cosine A is adjacent over hypotenuse, square root 3/2. Cosine B is its adjacent over hypotenuse, negative square root 15/4. Minus sine A was given, and sine B was given. Not that you couldn't still do sine A is opposite over hypotenuse, and sine B is opposite over hypotenuse. Of course that works. All right, our first one, we have negative square root 3 times 15 inside. On the bottom is 8, minus plus 1/8. Notice these two negatives make 8 positive. Inside the 3 times 15, 15 is 3 times 5. So notice we have a pair of 3's. So we can reduce. Give myself a little more space. There we go. This is negative 3 square root 5 over 8 plus 1 over 8. And maybe this is written as a common denominator. Then I put the 1 first because it's positive. And get that. We're looking 5, make sure that's a 5 in your notes. Excellent. Next problem. All right, this is a very similar setup to the previous one. But this time they're not telling us A is in quadrant 1 directly. They're telling us that A is between 0 and 90 degrees, which would be quadrant 1. So we set up a quadrant 1 angle for A. Cosine A, adjacent, square root of 10, over hypotenuse, 10. Pythagorean theorem, 100 minus 10 is 90. Square root of 90 is 3 square root 10. And this is positive. For the work for that, do a quick calculation for you. A squared plus b squared equals c squared, and a is square root 10, so square root 10 squared, plus b squared equals, and c is 10, so 10 squared. That's 10 plus b squared equals 100, so b squared equals 90. And now when we square root, we will get b equals square root, 90. And 90 is 9 times 10. And square root of 9 is 3, so we can pull out the 3, getting us 3 square root 10. Now it should be plus or minus, and the reason why it's plus is to the right is positive, and up is positive. So those are both positive, and hypotenuse is always positive. Okay, great. Back to the work at hand. They tell us B is between 270 and 360. That would put B in quadrant 4. So we set up a quadrant 4 triangle for B. Sine, opposite, negative square root of 3, hypotenuse 2. 2 squared is 4. Square root of 3 squared is 3, so 4 minus 3 is 1. Square root of 1 is 1. So that one works out to be 1. And sign check, right is positive, down is negative, hypotenuse always positive. Excellent. We have our triangles. Now we can proceed with our identity. Cosine of A minus B. This is cosine A, cosine B, opposite symbol plus sine A, sine B. Cosine A is adjacent over hypotenuse. Cosine B is adjacent over hypotenuse, plus sine A is opposite over hypotenuse. Sine B is opposite over hypotenuse. So for sine A, for example, opposite over hypotenuse. For cosine B, as an example, adjacent over hypotenuse. And then notice some of these are also given, so you can check them. But the triangle allows us to get them all very easily. Simplifying, our first one would be square root 10 over 20 plus, it's actually minus, negative 3 square root 30 over 20. We can write that as all over 20, the square root of 10 minus 3 square root of 30. Square root of 30 does not reduce because it's made up of 3 and 10, that is 3 and 2 and 5, and there are no pairs. That completes that problem. All right, last one. Okay, use identities for cosine of a sum or a difference, write as a single function of alpha. There's only one identity to work with. It's cosine alpha plus beta equals cosine alpha, cosine beta, opposite symbol minus sine alpha, sine beta. So this would give us cosine of alpha plus 90 degrees would be cosine alpha, cosine 90 degrees, minus sine alpha, sine 90 degrees. Now sine of 90 degrees is 1. Cosine of 90 degrees is 0, so we get minus sine alpha. And that completes this problem.